This ECE capstone project is a 360-degree passive thermal tracking device. Single target mode simply follows the target as they move about the room. The 8x8 pixel thermal array sensor, known as the grid eye, can be visualized on the laptop screen to the left. The payload, which for this project is a fan, sits atop a turntable that can swivel 360 degrees. However, due to mechanical restrictions, the turntable has a point it cannot pass. In the event that the target passes this point, the payload will rotate in the opposite direction to compensate. Varying options can be accessed via Bluetooth, in this case a phone, or via an LCD menu screen. For development and demonstration purposes, the device will beep when a target is found. The beeping will increase in pitch with proximity to the target. The plastic servo and drivetrain bend under torque, leading to heavy over and under dampening. If the target leaves the view of the grid eye sensor, there are 8 stationary PIR sensors on the side that detect motion, though they have limited accuracy. Multi-target oscillation mode will ensure that the oscillation is only between targets in the room. Once started, the device will sweep in all directions to enumerate all targets. This can only be done with the grid eye and not the stationary sensors on the sides, of which only detect motion instead of absolute temperature readings. After the initial scan, the device is now self-aware of all the targets in the room. If the stationary sensors detect new motion, the payload will rotate over those zones to confirm whether or not there's a target there and adjust the oscillation limits accordingly. Again, if movement is detected, only those zones are rescanned. This mode supports any number of targets, as it is only the outer targets that are significant. Avoid mode is fairly straightforward. One example application could be a pet toy on a string. Another application could be an industrial exhaust port. The Bluetooth connection is full duplex, allowing messages not only to be received by the device, but also to be sent by the device back to the user. In this case, a stall was detected and a warning was sent. An LCD menu allows for control without a remote device. Different tracking and payload options can be selected. The display can also show sensor output. Tracking with the grid eye is done by column. You can see at the bottom of the screen bars that indicate potential targets, with the green bar indicating the strongest point on the target, which is assumed to be the center. The software used for this visualization is known as processing, and the IDE is very similar to that of the Arduinos. The raw data from the grid eye is fairly noisy. There is a lot of flickering in each pixel. In this version of the script, a moving average is used. Notice the reduction in flicker. The servo had a range of 180 degrees, so to get 360, a gear train increases the range by sacrificing torque. This drivetrain would benefit from metal components as the axle would bend, resulting in a slow response. While the servo used had its own internal potentiometer for measuring the angle, it was much too noisy. An external potentiometer was added to the drivetrain.